Hello, my name is Vincent, and today I'll be talking about hydrogen fuel cells. So, start by talking about what is a hydrogen fuel cell. Well, it's a lot like a battery. It converts chemical energy into electrical energy, but a fuel cell does not need to be replaced like a battery. Instead, it uses fuel, such as hydrogen. And the overall cell reaction is two hydrogen molecules reacting with an oxygen molecule, producing two water molecules. As you can see, there's no pollution being produced because only water is made. So what's the difference between a hydrogen fuel cell car and a regular one? Well, on the outside, it may not seem very different, but inside we see a fuel stack instead of an engine. And we have hydrogen fuel tanks to store the hydrogen, which supplies fuel cells. Now let's take a look at an individual fuel cell. An individual fuel cell has an anode, a cathode, and a proton exchange membrane. On the anode side, hydrogen molecules are split to protons and electrons. The protons move to the cathode over the proton exchange membrane, this way, which reacts with oxygen on the cathode side, forming water. Meanwhile, the electrons, which are on the anode side, move on a different circuit to power the car or whatever needs to be powered. So that was just one cell. What happens when hundreds of these cells come together? Well, you have hydrogen fuel cell stack. One cell produces less than 1.16 volts of electricity, which is not a lot. But when a lot of these are stacked together, you have enough power to perhaps power even a car, such as the Honda FCX Clarity, which is one of the very few fuel cell vehicles released. And this one's much quieter and cleaner than a regular car. Both the fuel stack and the battery are small and compact. However, it's only available in Southern California because of the access to refueling and service stations. Well, let's talk about hydrogen fuel. Well, hydrogen itself doesn't occur naturally, so there are two ways to get it. One's steam reforming, which you can see on the left. It's basically reacting steam at high temperatures with fossil fuel to make hydrogen gas. The chemical reaction for this is steam plus methane gas yields hydrogen gas and carbon monoxide. As you can see, carbon monoxide is not a very good product. Another method is electrolysis, which is the splitting of water into hydrogen and oxygen. This one is not as efficient as steam reforming. And on the right you can see a hydrogen fueling station. So, what are the pros and cons of hydrogen fuel cells? Well, the pros of a fuel cell is that it does not produce carbon dioxide directly and is very fuel efficient, much more than a regular internal combustion engine, and it's also light and compact. It could also reduce our dependence on foreign oil. Well, on the other hand, they're expensive to make because the proton exchange membranes are made of platinum, and platinum is a very expensive metal. And it also requires the need to convert to a hydrogen economy, and that would take a lot of time. And also, hydrogen fuel needs more energy to make than it yields when it burns or in a fuel cell. So, in conclusion, hydrogen fuel cells do have a lot of potential to become our next energy source. but it takes a time to turn into a hydrogen economy, but with more time and research, it will become more efficient and cheaper. And that's all. I hope you enjoy my podcast.